We think of planets as loyal companions, faithful bodies orbiting the stars that gave them birth. Earth orbits the Sun, Jupiter, Saturn, Neptune, all part of the vast, clockwork system that makes up our solar neighborhood. But not all planets follow that rule. Some planets are different. Untethered, adrift. They have no sun, no orbit, no parent star to warm or guide them. These are the rogue planets, cosmic loners, wandering the galaxy in silence, exiled from the systems that may have once held them. For years, we barely knew they existed. Now, we suspect there may be billions of them, perhaps even more than the number of stars in the Milky Way. And yet the deeper mystery is not just how many there are, but what they are. What happens when a planet is born into darkness or thrown into it? Could it still harbor heat, oceans, or even life? Are rogue planets truly alone? Or have we simply failed to see what's hidden in the dark? This is the story of the most mysterious worlds in the universe, the ones that orbit nothing but possibility. Imagine a planet, vast, heavy, ancient, drifting alone through the void of interstellar space. There is no sunrise, no seasons, no light from a nearby star. Above, only stars. Below, perhaps frozen rock, or maybe something stranger. This is a rogue planet, also called a free-floating planet or an orphan planet. These are worlds that do not orbit a star. Instead, they wander space freely, untethered to any solar system. And as strange as that sounds, they may not be rare at all. In fact, according to some estimates, the Milky Way may be home to trillions of rogue planets, far outnumbering the stars themselves. But how could so many planets end up without a star? There are two main theories. The first, they were born that way. The second, they were cast out. In the chaotic early days of planetary formation, stars are surrounded by swirling disks of gas and dust, the raw material for building planets. As these planets take shape, they interact gravitationally with each other. If one gets too close to a larger neighbor, it might be flung outward, escaping the star's gravitational pull entirely. It becomes a planetary orphan, doomed to drift alone. Other rogue planets may form on the outskirts of their systems, never strongly bound to their star in the first place. Over time, a passing star or galactic tide might gently push them into the void. It's violent, chaotic, but it happens, and it's likely happened billions of times. Some rogue planets may even be stolen, captured briefly by another star, then released again. They are survivors of cosmic turbulence, worlds without homes. But that doesn't mean they are dead. If a planet doesn't orbit a star, you might assume it would be cold, frozen, and lifeless. And in many cases, you'd be right. But not always. Some rogue planets, especially those the size of Jupiter or larger, may retain significant internal heat. This heat can come from leftover energy from their formation, radioactive decay, or even from gravitational compression. Massive rogue planets may have thick insulating atmospheres, rich in hydrogen or methane, that trap heat and prevent surface temperatures from dropping to absolute zero. Others may have subsurface oceans, buried beneath icy shells, warmed by internal heat. Just like the moons Europa and Enceladus in our own solar system, a rogue planet could host a liquid ocean beneath a frozen crust, a stable, warm environment, protected from space. And where there's liquid water, there's the potential for life. The biggest challenge with rogue planets is simple: we can't see them. Without a nearby star to reflect light, they are almost completely dark, cold, invisible to most telescopes. But in the last 2 decades, astronomers have gotten clever. Some rogue planets have been detected through gravitational microlensing, a phenomenon where the rogue planet passes in front of a background star, briefly magnifying its light due to the warping of space-time. Others have been spotted in the infrared spectrum, glowing faintly from residual heat. In 2021, NASA's Nancy Grace Roman Space Telescope and the Euclid mission by the European Space Agency began preparing to search for rogue planets in bulk, and preliminary models suggest we may find billions of them wandering just in our own galaxy. Among them could be gas giants, ice worlds, rocky super-Earths, or something entirely unfamiliar. We may even find planetary mass objects that never had a chance to orbit anything, formed directly from a collapsing gas cloud, like stars do, but too small to ignite nuclear fusion. A blurred line between planet and brown dwarf. We are biased toward light. We study sunlit planets, analyze starlight, imagine life under blue skies. But rogue planets challenge that bias. They force us to imagine worlds without sunlight, where warmth comes from within, not above, where oceans are hidden and light is irrelevant. Some scientists believe rogue planets could be more stable than starbound worlds. Without a host star to flare, swell, or die, their environments might remain unchanged for billions of years. Could such a planet develop life? And if so, how would it evolve in a world with no day or night? No sunrises? No seasons? Would its life be bioluminescent? Chemosynthetic? Subterranean? Could an intelligent species arise, building a civilization in darkness, forever unaware of stars? It's speculative, but it's not impossible, and it raises a haunting question. Could there be life in the dark, floating silently between the stars? The word rogue implies isolation, a loner, a castaway. But what if rogue planets aren't alone? Some may have moons, bound to them through gravity, orbiting in a quiet ballet through the dark. These moons could experience tidal heating, generating their own warmth, and possibly even hosting subsurface oceans of their own. Others may travel in pairs, binary rogue systems, two planets bound to each other by gravity, drifting together forever. And still others may form temporary systems, passing close to stars, stealing material, or even being briefly captured before escaping again. A rogue planet's life may be long and silent, but not empty. It may collide, capture, interact, influence, and perhaps be visited. What if rogue planets are not just destinations, but stepping stones? Some scientists have proposed using rogue planets as way stations for interstellar travel, objects that could be mined, colonized, or even used as slow-moving vessels themselves, carrying resources or life from one part of the galaxy to another. Others have wondered if rogue planets might be refuges, backup homes for life during catastrophic cosmic events. If a star becomes unstable, a rogue planet might offer a temporary haven, shielded by distance and isolation. And then there's the most speculative idea of all. What if alien civilizations live on rogue planets right now? Hidden, isolated, shielded from detection. Without a star, their planets emit no telltale signals, no transits, no light curves, nothing to betray their location. They could be the perfect place to hide. A rogue planet could drift through the galaxy for billions of years, undetectable, untouchable, and completely self-contained. A silent arc in the cosmic sea. Ultimately, rogue planets expand our definition of what a planet is and what a planet can be. They show us that warmth doesn't have to come from light, that life might not need a sun, that loneliness in space is not the same as emptiness. They challenge our assumptions about where to look for life and what signs we should be looking for. And perhaps most profoundly, they remind us that not all who wander are lost. Some worlds drift alone by fate, others by force. But even in the dark, they remain part of the great cosmic story, chapters unwritten, waiting to be discovered. They are not mistakes. They are not leftovers. They are possibilities. And in the silence between the stars, they are still moving.